Hi, my name is Marina Hartogs, and today I'm going to be teaching you how to do the second FRQ question from the 2003 AP Calculus AB test. A particle moves along the x-axis so that its velocity at time t is given by this equation for velocity. At time t equals 0, the initial position for the particle is x equals 1. So part A asks to find the acceleration of the particle at time t equals 2. Is the speed of the particle increasing at t equals 2? Why or why not? So in part A, we're trying to find the acceleration of the particle at time t equals 2. So we know that the acceleration is equal to the derivative of the velocity. So we're going to take our calculator and do math derivative, and then we're going to plug in the velocity function. And then we're going to evaluate it at x equals 2. So we found our answer to be 1.588. Next, we need to determine whether the speed of the particle is increasing or decreasing at time equals 2. So to do this, we need to first solve for velocity at time 2, which is equal to -3 times sine of 2 which is equal to -2.728, which is less than 0. Since acceleration and velocity have opposite signs, then we know that the speed is decreasing. Part B says find all times t in the open interval 0 is less than t is less than 3 when the particle changes direction. Justify your answer. So the particle is going to change direction when the velocity function has a 0. This is because the velocity of the particle will either change from positive to negative or negative to positive. So you look at the two components of the velocity function, and the first part, this can only equal 0 when t equals -1. However, the interval is from 0 to 3, so t cannot equal -1. So for the second part, we know that sine of pi is equal to 0. We also know that sine of 0 is equal to 0, but then t would equal 0, which is not on the interval. So we want to set t squared over 2 equal to pi, cross multiply to get t squared equals 2 pi, and t equals plus or minus the square root of 2 pi. And only the positive root is on the interval, so we're just going to keep the positive one. To confirm that the particle changes direction at this t equals the square root of 2 pi, we're going to test values in the different intervals. So on the interval 0 is less than t is less than square root of 2 pi, we're going to test the value 1, and the velocity at that time comes out to be -0.959, which is less than 0. For the interval the square root of 2 pi is less than t is less than 3, we're going to test the value 2.7, and that comes out to be 1.785, which is greater than 0. Since the values of the velocity change signs between these two intervals, we can confirm that the particle changes direction at time square root of 2 pi. Part C asks to find the total distance traveled by the particle from time t equals 0 until time t equals 3. So we know that the displacement is the integral of the velocity function. But we need to be careful because if we do the integral from 0 to 3 of v of t dt, we are only going to get the displacement, not the distance traveled. For example, if a particle travels in this motion, this integral here will find this displacement from here to here. And we need to find the total distance it traveled. So to account for these changes in directions, we need to find the integral from 0 to 3 of the absolute value of v of t dt. And that will give us the distance. So now we need to plug this equation into our calculator. So we click Math, and then Integral from 0 to 3, and then we do Math, Numbers, Absolute Value, and then from there we're going to plug in our velocity function, which is so from here we find that the total distance traveled is equal to 4.334. Part D asks, during the time interval 0 is less than or equal to t is less than or equal to 3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. To find the greatest distance between the particle and the origin, we are going to need to test the point, the square root of 2 pi, because since it is a 0 of the velocity function, it is a critical number of the displacement function, or the position function. But what you can't forget is to also test the endpoints, which are 0 and 3. So we know that at the time t equals 0, the particle is at position x equals 1. So to find the distance from the origin, we need to do 1 for the initial position plus the integral from 0 to 0 of the velocity function. So we know since it's from 0 to 0, that part's just going to be 0. So plus 1 equals 1. For the square root of 2 pi, we need to do 1 plus the integral of 0 to 2 pi of the velocity function. So to solve for this, we can just plug it into the calculator, and we're going to do 1 plus math integral from 0 to the square root of 2 pi, and then we're just going to plug in the velocity function. And we are going to get negative 2.265. So then we're going to do the same thing for 3 and do 1 plus the integral from 0 to 3 of the velocity function. And then, so we can plug this into the calculator, and we're going to do 1 plus math integral from 0 to 3 of the velocity function, so we can just plug that in again. And for this one, we are going to get negative 1.19715. And so, since we are looking for the farthest distance from the origin, we're going to take the absolute value of these numbers. So we're going to have 1, 2.265, and 1.19715. So we know that the greatest distance from the origin is going to be at the point 2.265. Some similar problems that may help to give a better understanding are FRQs 1999 number 1, 2009 number 6, 2011 number 1, and 2012 number 6. Thank you for watching. I hope this video helps.